Okay, I am now looking at the visual learning page and the Convince Me on page 500. This is for lesson 8.8 using the scaling again. So hopefully you watched the visual learning video on Pearson Realize. You can also look at the top of the page 500 to see the problem that the Convince Me is based on. So for the Convince Me, we are going to use the chart at the top with Sue and her scarves. So Sue knitted a scarf for her friend June that was also 4 feet long. So if you watch the visual learning, you know that they said some of Sue's scarves that she knitted for her friends shrunk and some of them stretched. So for June's, it was 4 feet long. That was the original length. And after a month, the length of June's scarf could be represented by the expression 3/3 times 4. I just flipped it around, 4 times 3/3. So the question is, how did the length of June's scarf change, and explain? So if we're representing it with this number model, the question is, did it change? So if this was the original length and they're telling us to multiply it by 3/3, I know that 3/3 is equal to 1 whole. So if we multiply the original length times 1, we get an answer of 4. So this question, based on her original problem at the top, where some of them stretched and some of them shrunk, is that June's scarf actually stayed the same, because the answer is exactly what her beginning length of her scarf was. Okay, jumping over to page 501 on the guided practice. I'm going to go through these with you before you do the independent practice. Question number 1, why does multiplying a number by 3.5 increase its value? And like I have said with any of these problems now, if you go back to the previous lesson, or if you go back to the solve and share for this lesson, anytime I'm multiplying by a number that's larger than 1, it's going to give me a larger product at the end. So if I do 3.5 times 2, I'm going to get a larger number than if I did 1/2 times 2, because this number is greater than 1. Again, if I did 2/2 times 2, 2/2 is equal to 1, so I know my answer is going to be exactly 2. As I go under that fraction and do 1/2, 1/3, 1/6, 2/5, anything under 1 is going to give me a smaller number. Anything above 1 is going to give me a larger number. Okay. Number 2, does the scaling factor always have to be the first factor in an expression? So on any of the problems that we're doing, the question is really asking, does it matter where the numbers are in the number model? So if you take a look, for example, at question number 3, the question is 3.5 times 2 2/3. They're basically asking us, does it matter if I put the 3.5 here, or can I put it there and switch the 2 2/3 over there? So if my number model looks like this, whoops, that's 2. Am I going to get a different answer for each of those? And obviously the answer is no. I don't get a different answer depending on where my factors are, because again, if you go all the way back to when you first learned your multiplication facts in 2nd or 3rd grade, I know that the order does not matter. So if I do 2 times 3, it's 6. If I do 3 times 2, it's also 6. Order does not matter for the answer. Okay, so jumping up to this problem now, they're asking us 3.5 times 2 2/3, and they're saying there's another 2 2/3 here. They want to know, is this side greater than, less than, or equal to this side? So again, we don't have to actually solve all these problems out. I know that this is my number that I'm going to be looking at, because that's my answer also. And when I have this 3.5, again, think about the numbers in terms of 1. So if this number is staying the same, if this number is smaller than 1, then that side's going to be bigger. If this number is bigger than 1, and I'm multiplying it by that number, it means that that side's going to be bigger. So 3.5 times 2 2/3 is greater than 2 2/3. Okay, looking at the next one, we have 4 fifths times 2 2/3. How does that compare to 2 2/3? So again, same idea. My 2 2/3 in both places. So I know so far that 2 2/3 is the same as 2 2/3, but when I multiply 2 2/3 by a number, now this time I'm less than 1, what's going to happen to this side of the equation? So again, less than 1 times 2 2/3 is going to bring me a number, because remember, this is going to bring this number down. So my sign is going to look like that now. 4 fifths times 2 2/3 is less than 2 2/3, meaning my answer is going to be going down. Okay, and for the last one, number 5, 4 3/5 times 4 fourths, and they want us to compare it to 4 3/5. So when I take that original number, same number on the side, but this time I'm multiplying it by a fraction, what is going to happen to it? Remember, 4 over 4, 4 fourths, is the same as 1. Anytime I multiply any number, including fractions, by 1, I get the same number. So my comparison is going to be equal. 4 3/5 times 4 fourths is the same as or equal to 4 3/5. Okay, so you notice in all of these problems, what I didn't do is I didn't do any of the actual multiplication. So with the exception of in the solve and share, I just showed you that one where I actually worked the problems out. I didn't have to do that for any of these. So when you go to the independent practice, I want you really to look at each of the fractions, and the easiest way to think about it, again, if I see a fraction where my numerator and denominator are the same, for example, 2 halves, 3/3, 4 fourths, 5 fifths, and so on, so numerator, denominator, the same number, it's always going to be equal when I do my multiplication. If the fraction is smaller than 1 whole, the final comparison is going to be less than. If the fraction that I'm multiplying by is greater than 1, so anytime I have those mixed numbers, it's going to be greater than. Okay, that was page 501. If you have any questions, please drop them in the comments and I will get back to you. Have a good one.